Yep. All right. So, to give a brief overview, me and Elias took this project on as part of a junior force organization within our part of the lab called GIFWorks. For those of you guys familiar with the Sparks, that's kind of going on right now, the Spark movement. That's sort of what GIFWorks is, but we've been around for I don't know, about 10 years. And so we have customers come to us, warfighters usually with problems they need solved, and we usually take on stuff that has a direct material solution. So they need something made. We get it made, or we make it, or we design it and find them somebody to make it to solve their problem. So we had a group come to us. They said, "Hey, we have hard plate armor. It works, but it's heavy. It's uncomfortable. It's hard to wear." And they started to have problems with people not wearing it. We met a guy that used to take his out and put cardboard in his plate carriers. Cardboard was more comfortable. Obviously, that's not a good solution. So we started looking around for things that could solve the problem, flexible armor that could work. So currently, most people use a ceramic plate or a steel plate, and that's a strike face to slow down the bullet or rough it up and blunt it. And then they have a second layer of armor behind that, a soft armor, usually a polyethylene fabric, or a Kevlar is a good brand name most people are familiar with. And that's very heavy. Those ceramic plates are heavy. They're expensive and they're delicate. So we looked around. We went through a couple different companies and a couple different technologies, and then we found Dr. Ray over here at the Navy postgraduate school, and he's been working for quite a long time on this type of flexible armor. So what he's done is he's taken ceramic balls, which are their industrial product. So for these, they're actually a precursor to ball bearings. So it's not a specialty product by any means. Buy the balls, put them in a mold, spray the mold with a foam. The foam holds together the balls. You flip it over. You put polyethylene, so the same kind of soft armor that's backing the current plate. You can put that inside the foam, behind the balls. Spray another layer of foam, let it cure, and then it holds together. So it's essentially the same idea with a ceramic strike face backed by a soft armor, but because of the foam and the ball construction, it's flexible. It can move around. It can withstand more than one hit. So ceramic armor, the plate, you get shot once, cracks the whole plate. Try not to get shot again. The balls, you hit the balls, it will destroy square couple inches. But if you get shot in a different part of the plate, you still have this ceramic strike face in place. So, and then the other benefit is you can make this armor moldable. So one of our customers, their need was concealable armor. And with this, because it's flexible and because you pour it into a mold and spray the foam in, you can make whatever you want. So this, we actually 3D scanned a guy and then 3D printed his chest and then poured the mold into that. So this one was a failure. We didn't get good penetration by the foam, which is why you can still see the balls, but it just shows the moldability of it. So a lot of work has gone into this armor over the years. They used different types of ceramics, different sizes of balls. You can see in the pictures they used different sizes of balls together, try to fill in the interstitial spaces, and they kind of just work their way through it. Try this, is it better, is it not? Body armor is an easy science. There's no, there's not really, is it a better, does it still stop bullets? Okay. If it stops bullets, then okay, is it cheaper? Is it lighter? There's other stuff you can look at, but it's pretty easy, a go, no-go thing. Does it stop? So currently, for those familiar with armor, the current one we're working the most on is a NIJ level 3, and this is a full-up prototype. It can stop. So NIJ level 3 is essentially like an armor-piercing AK. The highest level is a level 4, and we're working towards a level 4. Ray's currently got one that's the same idea, but the polyurea foam is hard, so that the level 4 is not flexible yet. But we're still working on that. So as you can see, very flexible, very comfortable. Um, so you can see that here, this is actually one of the customers we're working with is the Air National Guard. They're very interested in it, so we made this some prototypes. This is one of the extras from that same set. So we shipped it to him and asked him what he thought. The armor is very flexible in one direction. Obviously, you can see in the pictures, it's kind of flexible in the other direction. And that's just how it's constructed with the polyethylene fabric on the back. So we're working with the Guard to kind of determine, you want flexible armor. Is this flexible enough? Is it light enough? What do you think? And they've been very positive. They're very excited. We're working with them to see if this is good enough. We'll probably move forward this summer with certification testing. So on top of the benefits I've discussed so far, flexibility, multi-hit, you add especially what a lot of the warfighters looking for, lightweight. So you can see here we had them weigh the current kit they're outfitted with. There on the right, he got 4.4 pounds, and then our prototype's 3.6 pounds, so about 20%. And then you also have to take into account that our armor is a one piece. So the soft armor is encapsulated within the foam. His armor, he just weighed the hard plate, but they do have a soft armor that he didn't include. So about 20% for the system in weight saving. So, and then he also said he really liked it because it acted as a pad for his batteries and radio. So it was super comfortable. So that was good. We didn't think about it being a pad. So here's just kind of, we're better in every way sort of thing. It's our armor is essentially half price of a standard ceramic plate, or replacing. It can float a little bit depending on what polyethylene you use. And the Navy postgraduate school is working on kind of working out what are the benefits. But again, if it stops bullets, it's bulletproof. So you start looking at other stuff like weight, cost of the polyethylene. And then one thing I didn't cover too much, but because it is a closed cell foam, it's also neutrally buoyant. We did have some customers from the first AFWorks event come to us and ask us if it was actively buoyant. We haven't really worked on that because we hadn't had a customer that came to us and, hey, will it float me around the river? But we can work on that if we see a big push. It's just a matter of kind of tweaking the foam and seeing what happens when you shoot it. So future work, we're gonna move forward with NIJ Level 3 flexible this summer. There's a little bit more development that we're gonna work with Ray on, and then we'll get it tested for certification. So we're trying to finish that by the end of the fiscal year. And then one thing we're looking for is manufacturing partners. So the armor's not hard to make. It's all pretty bog standard stuff. The balls you buy in big barrels. The foam is pretty standard. Ray works with a company that makes the machines that spray the foam, and they make the precursor ingredients that go into the foam. So there's nothing real complicated needed, but we just need to find a company that's comfortable working with us. Again, the Air National Guard, very positive. They're looking to roll out, I think 500 sets once we get it certified for further testing, and then we'll keep working on the Level 4. It's not flexible yet, but it does add all the other benefits of half price and neutral buoyancy and multi-hit. So we'll keep working on the flexible and then see where we're at. But I think that's all I got. Any questions? Yeah. Yeah, so that's kind of along the lines of looking for a manufacturing partner. It's the process of scanning somebody and printing the mold and making the armor is not complicated. These prototypes, me and Ray made them in a garage in about 4 hours. So it's not hard to make, but in terms of our position, we're the lab, so we can't make products. We can only make prototypes. It's just the way our money works. So that's pretty much why we're here is to work with a manufacturer. But we've pitched this a few times, and it's kind of a niche thing. You can't roll out custom armor to everybody in the world. Like, that'd be prohibitively expensive. It's not cheap, and it's not a very quick process to print a 3D mold. But if we can find a manufacturing partner, the molds are pretty, you know, okay, well, we need more balls because this mold's a little bigger. Spray a little bit more foam until you cover up everything. But yeah, it shouldn't be hard if that's really what you want to do. Yep. Mm-hmm. So that's something we haven't really been able to test. It's hard to find people that wear body armor in a situation in which they're not going to possibly be shot. And that's sort of the operational testing stuff that we're trying to work with the guard. So here, wear this. They do a lot of. They're the test center, so they're testing a lot of other stuff that they'd want to wear their armor for. Like, hey, can I get in and out of this new, this new four-wheeler with my armor and everything on? So they're a good partner for us. They haven't had it long enough to really understand those, but from a scientific point of view, most of the development of the technology was working on the foam to make it tensily strong enough to hold together, get shot. So I honestly can't imagine having any problem with it wearing out in terms of like pulling apart. In terms of abrasion resistance, it might be more, if you put a wrapper around it. We haven't had any problems with abrasion resistance. I haven't seen anything. Ray, have you seen anything in terms of abrasion or? Probably is the foam. Um, so the biggest time suck is you have a mold, standard plate size mold, placing the balls so there's no gaps, pictures the balls. That takes 30 minutes per plate because it was just waggling them back and forth. A simple shaker table I would think at least cut that into half. So the cure time on the foam with an oven is an hour and a half. Okay. Yeah. So to handle it once you spray the foam on, it's 50 minutes. For it to be full on, about 3 hours. So, roasting in the oven. That's tough to answer. That's really my day job is materials and manufacturing. That's kind of my background. Um, and when you start talking about how long does it take to make a mass amount of stuff, it really depends on what your cutoff level is. So if you're making 100 plates, you're going to buy a shaker table and you're going to pay some guys to come in and set the balls. If you're going to make 10,000 plates, you're going to pay a guy to write AI software to scan the plates to see if there's any gaps in the balls. So there's going to be different cutoff levels that you get depending on your scalability. At 500 plates, you're still probably just looking at manual labor, and you could crank out. I would say it'd be 4 man hours a plate, 5 man hours a plate. It would scale up, depending on how many people you hire, how many foam machines you want to buy. Not long. Yep. Ray. So to kind of sum it up, it's going to be better than what we're replacing because it's multi-hit, because the foam will absorb some of the. Yep. We have another group, the Battlefield Airmen. Um, yep. And they're mostly interested in a level 4 because they're required to wear level 4. Yeah, and we know that we've seen that push. That's why we're working towards a level 4. Got this one like 50 times. All right. Any other questions? Oh, sorry. Yeah. So that would come later when you're talking manufacturers and the liability that the manufacturer would be willing to pursue. I don't think polyurea ever breaks down. So that's one of the things that us in the Air Force are trying to work with Ray, meet the customers, find out what ours are. Is it durable enough out of a pouch? That's some of the stuff that we can spend our money on. The testing that to figure out the requirements. Any other questions? Great. Thanks a lot.